at oblique triangles. Remember, an oblique triangle is one that is just not right. So if it is not a right triangle, we can't use like sine, cosine, tangent, secant, cosecant, cotangent, Pythagorean theorem, any of that kind of stuff. We can use law of sines and law of cosines. And it depends on what kind of a triangle it is as to which one we're going to use. We will use law of cosines for a side-angle-side triangle and for a side-side-side triangle. Those are the two that we'll use law of cosines for. Now, here's why we need law of cosines. Here's a side-side-side triangle down here. And notice that if you tried to solve that with law of sines, it's not going to work. Remember when we're doing law of sines, we need like two pairs. We need a pair of A's and a pair of B's, or a pair of B's and a pair of C's, or a pair of A's and a pair of C's. And you have to know 3 of those 4 pieces, right? So if I try to go through and say A is to A as B is to B, I don't know either angle A or angle B. I can't solve for 2 unknowns at the same time. And the same thing would happen no matter how I tried to set that up. So that's why I need something else to help me with these 2 types of triangles. What a lot of people tend to do is they try to set it up with law of sines, and then if they don't have the pieces that they need, then they switch over to law of cosines. So here's law of cosines. On page 437, they actually give you 6 different formulas for law of cosines. They give you 3 in standard form and 3 in alternative form. Let me show you a way to maybe remember those a little easier. So first off, in the standard form, look at that very first one. A squared equals B squared plus C squared minus 2BC cosine A. A way to remember that is, notice that whatever the angle is over here, like this was angle A, that's the same side that you're going to be solving for. So we're going to call that the side opposite the angle. So that would be side A if this is angle A. All right. So it's the side opposite the angle squared is equal to the other 2 sides squared. So if this was A, this has to be B and C, minus 2 times those same other 2 sides, B and C, times the cosine of A. So if I kind of remember that pattern, then I could go through and I could use B squared and C squared the same way. The alternative forms just come from solving the standard form for the angle. For instance, here's that standard form. If I went through and I solved for cosine A, I'd have to subtract the B squared to the other side and subtract the C squared to the other side. So now I've got A squared minus B squared minus C squared equals negative BC cosine A. To get cosine A by itself, then, divide both sides by the negative 2BC, divide both sides by the negative 2BC. When I do that, they're going to divide through by this negative right here, so that's like multiplying the whole numerator by negative 1. So that would give me negative A squared, positive B squared, and positive C squared, all over the 2BC. Okay? So that is the alternative form there that you see for cosine A. So you can memorize all 6 of them. If you like making flashcards, you're welcome to do that. Or you can memorize the format and use that to create all 3 standard forms, and then you can just solve for the alternative form, whatever works for you. All right, so let's see how we can use these. For example number 1, we've already talked about that's a side-side-side triangle. What a lot of people like to do, law of sines seems to be a whole lot easier to remember and a whole lot easier to use. And so what a lot of people like to do is find one missing piece with the law of cosines, and then once you've got that, then you could switch back to law of sines, right? If I think that might be what I want to do, the only thing that we don't like about law of sines is that ambiguous case, right? That thing that sometimes we get 0 answers and sometimes we get 1 and sometimes we get 2. There is no ambiguous case with law of cosines because that's only with a side-side angle triangle, right? This is not side-side angle, this is side-side-side. So if I think that I might want to switch back and finish solving this problem with law of sines, and I want to avoid running into the situation of the ambiguous case and not knowing what my right answer is, what I can do is solve for the largest angle first. If I do that, I will completely avoid that situation. If in this case, how do I know what's the largest angle?
The largest side.
Yeah, it's got to be opposite the longest side. So angle B has got to be my largest angle, so I'm going to solve for angle B. if I did not do that, if I solved for angle A first, and then I switched over to law of sines. All right, so again, if I had solved for angle A here first, and then I switch over to law of sines, I'm going to come up with two different answers at the end, like I always do with law of sines. And the problem's going to be that in some cases, both of them will work. They'll fit in my triangle. One of them is right and one of them is not. There are not two solutions for a side-side-side triangle. I literally will have no idea of those two answers, which one's right and which one's wrong, and I'd have to go back and redo the whole thing all over again. Okay? So again, the way to avoid that is solve for your largest angle first, and that way if you decide to switch back to law of sines, you will avoid that ambiguous case and not have to worry about it. Okay, so if I'm trying to find angle B, I'm going to go through and plug in what I know. So I know little a is 8, so 8 squared is 64. I know little b is 19, so 19 squared is 196. And I know little c is 14, so 14 squared, oh, sorry, I did that backwards. C squared, 14 squared is 196, and 19 squared, 361. And then down here in the bottom, we're going to put in A and C. All right, we throw that into our calculator. For this test and quiz, you're going to be working on a scientific calculator, not a graphing. I have a handy-dandy program on my calculator called Law of Cosines for an angle and Law of Cosines for a side that I will link to you after this test that you can use to find all of these things for you in the future. But for that reason, because some of you already have some of those things on your calculator as well, for that reason we will only use a scientific for this test and quiz, not a graphing. So it's a good idea while you're doing these homework problems or these examples to practice with the scientific instead of practicing on your graphing. All right, so are we saying here that angle B is equal to a negative 0.45? No. The sine or cosine today, when we were looking at 6.1, it was the sine. But the cosine is negative 0.45. Not the angle itself, but the cosine of the angle. So we're back to Jeopardy, right? I know the answer. I'm looking for the question. So what do? Inverse cosine, right, or arc cosine. So I'm going to do inverse cosine or arc cosine of that decimal, and that will give me my angle. So angle B is equal to 116.8 degrees. How come I get two different possibilities with law of sines, but I don't get two different possibilities with law of cosines? Well, here's the idea. Can you have a third or fourth quadrant angle in a triangle?
No.
Why no?
Because it's 180 degrees.
Yeah, something that's in the third or the fourth quadrant is larger than 180 degrees, right? You only have 180 degrees for your whole triangle. So you can't have an angle in that triangle that's larger than 180. So no possible way to have a third or a fourth quadrant angle in your triangle. That means that you only have first and second to choose from. Well, here's why law of cosines is so great. Because in the first quadrant, cosine is positive, and in the second quadrant, cosine is negative. So there's only one possibility. If this was a negative value, then I have to have a second quadrant answer. If this was a positive value, then I'd have to have a first quadrant answer. Literally, when I type it into my calculator, it will shoot out the one correct answer. There is no finding a reference angle, subtracting from something else, calculating a different quadrant, none of that. So that's really nice. I know that angle B is 116.8. All right, so now I have a pair of B's, right? So I could keep going with law of cosines. No problem with that at all. I could come over here and either find C or A using the alternative formula, just as I did to find angle B. I also, because most people think it's simpler, could switch back to law of sines now because I have a pair. So I could say, okay, I know angle B, I know little b, and I know little a. That's 3 of the 4 pieces, so I could find angle A. All right, so how am I going to find angle A? Multiply by 8, right. So I'm going to multiply both sides by 8, and then I'm going to throw that into my calculator. And again, we're not saying angle A is 0.376. we're saying the sine of it is 0.376. So how do I get back to angle A? Inverse sine or arc sine, right. So that gives me 22.1. And again, when we were doing law of sines, we would say, okay, there could be an answer in the first quadrant or in the second quadrant. So my first quadrant answer is my reference angle, but then I got to come over here and find my second quadrant answer. Because I found the largest angle first, then that second quadrant angle is going to dump out, and I won't have any confusion, no ambiguity. I won't have any question as to which one of those is the right answer. So I'll know that angle A is 22.1. Okay, so once I know angle A and B, how do I find angle C? Yeah, add them together, subtract from 180. And so that'll give me 41.1 for angle C. So that's how I solve a side-side-side triangle. All right, the second type of triangle that we said that we would use law of cosines for is a side angle side triangle. Side angle side is when I know two sides and one angle, but it has to be the angle in between those two sides. So side angle side is when I know two sides and the angle, but it has to be the angle in between those two sides. So example number 2 is like that. I know two sides and I know the angle in between them. So that's side angle side. Now, if you look at all 6 of those formulas, all of them have an angle, either A, B, or C in it, right? So in my side angle side triangle, I only know one angle. I only know A. So that lays out for me which formula I have to use. I have to use the formula that has angle A in it. So that means I'm going to have to find little a. All right, so we can go through and plug in what we know. We know that little b is 15, so 15 squared is 225. We know little c is 10, so 10 squared is 100. And again, b was 15, c was 10, and then angle A was 115. Here is the most common mistake that people make with law of cosines. All right? We want to simplify this a little bit before we throw it into our calculator just to save us a few keystrokes. And so we come over here and we say 225 plus 100 is 325. And then we say 2 times 15 is 30 times 10 is 300. So 325 minus 300 is 25. So I need 25 times the cosine of 115. What's wrong with that? Nothing. That looked pretty good to me. Yes. The 2 times 15 times 10, that 300 has to get multiplied by cosine 115 before I come over here and start adding it and subtracting it to other stuff. Order of operations says do all multiplication and division first before you do addition and subtraction. You will not get the same answer if you do that. So be careful. We would want to do 300 times cosine 115 and get that answer, and then do the 225 plus 100 combined with that value. So when we do that, we'll get 451.7854785, and then we just need to take the square root of both sides. Something else that's really great about these non-right triangles is that we're not working in a unit circle with quadrants, where quadrants determine whether our answers are positive or negative. These are distances. They're lengths of the sides of a triangle. They are always positive. That's nice, right? We'll take it. All right, so once again, once you find one piece, you may decide that you want to switch back to law of sines. And you'll notice that I have a pair now. I could say sine of A is to A as sine of B is to B, or sine of C is to C, because I would have pieces to be able to do that. Go ahead, we can set our A's equal to our B's, or our A's equal to our C's, whichever way you want to go. I'm going to do A's and C's. Plug in what we know. How are we going to get angle C by itself? Multiply by 10. And then we'll do inverse sine in our calculator. And again, we'll get 2 different answers, but because they gave us the largest angle, we know that this one's not a possibility. so we know which one is the correct answer. And once you know 2 angles of a triangle, how do you find the third one? Subtract from 180. So that's how we can solve a side angle side triangle. So law of cosines for side, 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 and side angle side, and we've done one of each. All right, the last thing that they give us is Heron's area formula, and we use it to find the area of a side, side, side triangle. In some math textbooks, this is called Heron's formula. It's the exact same formula. It finds the same thing. It's just, you know, something got lost in the translation of the guy's name somewhere along the way, I guess. But Heron's or Heron's finds the area of a side, side, side. All right, so if you'll notice in the formula, we have several S's. S is the sum of the 3 sides divided by 2. So when we start with example number 5 and they give me the 3 sides of the side, side, side triangle, I want to find the sum of the 3 sides and divide it by 2, and that'll be my S value. Sum of the 3 sides divided by 2, and that'll be my S value. All right, so when I figure out that S is equal to 84, then I can finish my formula. Because my formula says S, so 84, times S minus A, so 84 minus whatever our first side was over here, 43. So 84 minus 43. S minus B, so 84 minus B, which was 53. That was our second side. And then S minus C, and so C was our third side. It was 72. And then we can just throw that into our calculator. Because it's an area, we're going to give units squared. So meters, inches, centimeters, feet, whatever it happens to be you're working with, it's going to be a square unit.